So well, now we have seen the problem. Upsets will make you upset. How do you actually get past that problem? Well, that is why Cassandra introduced something called the lightweight transactions. It actually took things from the CAS principle, very common paradigm in concurrent programming. So what it does is you do something called if not exists. So this one is, hey, I'm going to insert into this particular table albums by performer, and in this value if it doesn't exist. So you do this explicitly yourself. So then it performs a read before write, and it will give you a Boolean value true if that statement succeeded, or Boolean value false if it failed. And the second one, obviously, just an example of true and false. Oh, what did I do? Sorry, I pressed the end slideshow by mistake.
Still replicating? You should use Oracle solution.
Yeah, I get paid by Cassandra for doing this talk. If I can do anyone's advertising if they just pay me well. So the next one here is TTL. Did I miss something over here? No. Yeah, there's one more in that was for the solution for primary constraint violation, and this is the solution for doing an update if it doesn't exist. So this will do an update only if that particular thing exists, that particular record exists. This is how we actually do it in lightweight transactions. But then lightweight transactions are quite heavy. If you compare the performance of a LWT in Cassandra with a normal RDBMS, RDBMS does much better job than Cassandra, just so that you know. Okay, that was quite an unpleasant surprise for me. That's why I said the first half I'm going to be a salesman, and the second half I'm going to be a critique. The second one is a TTL, which is quite a nice feature. So if I can put some value in seconds over here, after that time elapses, it's just going to expire and that record will cease to exist. And then how do you, okay, this is a very interesting, somebody just asked me, oh, the clustering columns, right. Here's the answer to your question. So the primary key of a table in Cassandra, or a column family, which is the neuter, contains two pods. The first pod over here is the primary key, and the second pod just behind that is the clustering column. How do you distinguish between a primary key and a clustering column? Because you put one bracket around the primary key and then you leave the second one behind that bracket. That would be the clustering column. So if you want to have composite primary key, you can put year, comma, I don't know, runtime in the primary key, in the partition key, and then the rest just the name in the clustering column. What does a clustering column do? It just groups the table's rows into partitions. Well, it all seems nice over here. This is where the ordering comes into play. Let's say you want to check, what is the question again?
Well, it's here, if you can check all the artists.
Exactly. So then what I will then do is I can put, instead of, I can do year as the prime, I can put year as a clustering column, and then I will see all the, we'll see an example over here. It's going to be a lot more clear. So here we have the names, some of my favorite movies from, as you can see, I like a lot of cartoons. It's not nice, a bit childish. So here 2015 is the primary key, as we saw, right? But then I put the movie name over here as the clustering column. So what then it will do is it will append that home, which is the movie name value, to each key. So in your case, so then what it will do, this is how it'll actually be stored internally. And for 2014, so you will see it as a table over there, and then internally it will be stored like this. But the reason why clustering column gives you a benefit is that you can actually query with a clustering column. So if in your case you want if you put the year as a clustering column, I can use that year in the var clause in a SQL query. So you can actually use anything which is a clustering column in the SQL query within the var clause. And obviously, as home comes before minions, because it's alphabetically sorted, it comes first and then comes minions. And you don't have to believe me, I actually have inserted 4 entries into the database table, and then I'll query the result, and you can see that home comes before minions because it's sorted. Yeah. Okay, querying clustering columns. Because now I have the name of the movie as a clustering column, I can use that in the query and I can get the result. Yeah? Okay, next one. Range. I can also do range query. Because it's sorted, I can say, give me where name is less than or equal to minion. So what it will do is it will just take everything from the database and then slice that list until the value is minions. So the range query is a lot more efficient. And if you have a date range, sorry, go on.
Yeah, are you limited to one clustering column?
No, you can have multiple. You can have composite primary key, composite clustering column. All that's possible. But don't do too many because, well, I get confused if I have too many clustering columns in the end, because I don't know how it is actually sorted in. Because mentally, I try and make a picture of how data is stored internally so that I can write sensible queries. If I put too many clustering columns, for me personally, the mental translation of table into maps of map becomes more difficult. But hey, you know, well, a lot of people are a lot more smarter than me, so maybe you do a much better translation in your head. So, well, as I just said, you have a composite partition key over here, and that's how it's stored. You see 2 values in here. That's a composite partition key. You have the name of the album and the year. Yeah, and then the track number is the clustering column. So then you get the track number and then the title. That's the music DB. I'm just going between music and movies. Sorry for the confusion. And we're back in music. And static column. Static column is quite simple. It contains the same value for all the rows. So if I have an album, yeah, obviously, if it's the same artist or the same genre, it's going to have the same value for, you know, all the tracks within the album. Well, these are the data types the Cassandra supports. So what is it that you find quite new or weird in here? Say again? Tuple. Good.
Map.
Fantastic. More?
Set.
Yeah, set. You see list, set, and map. All the Java collections are in here. Tuple is quite a nice one. What else?
Time, UUID.
Exactly. UUID and time UUID. That's a new pair in here. And then there is a difference over here. Yeah, varchar, and there is also another.
Varchar, I'm familiar with.
Yeah.
Varchar 2.
Varchar. Varchar 2 is varchar 2, but you can just use string or something like that. What is it?
Text.
Text, exactly, right, text.
Yeah, but the same thing.
They're the same thing. It's just that people coming in from the SQL world will find varchar more user-friendly because they don't have to learn something. But people that start with Cassandra use text, but it's the same thing.
Yeah, but you have the same thing in MySQL, text, non-text. Okay.
Well, anyway.
Tiny text, 256.
Hey, I'm not a DBA or a MySQL expert or any SQL expert. I'm just, well, anyway, I'm just saying that this is what I've noticed so far. But because a lot of people that are coming over to Cassandra are probably coming from Oracle world. Yeah, that could be a reason. Anyway, UUID is just a UUID that you create. And, oh, sorry. So it's a version 4 UUID separated by dashes. And time UUID has a time element in it. So you can get the date part of the UUID by using the data function. And then if you want to generate a time UUID, you just use the internal function now. And then counter. Counter is quite a neat one because imagine if you have a distributed database, you want to keep a counter of, you have to keep a count of something. At the time you use the data type called counter, but you have to take into account that when you use counter, that is the only thing that you can have in that particular table, and not any other element with another data type. You cannot, for example, have varchar of something. You cannot have, var int or I don't know, anything else in there, and that should not be primary key. The implementation of counter is done in a very neat fashion, but that it's a bit more complicated. It goes beyond the scope of this talk. But yeah, just keep in mind for update of non-counter, for counter columns is a lot slower. You can only do, you cannot set the value of a counter. You can only do increments or decrements. And by default, the counter is initialized with 0, and you cannot just simply retry. There is an idempotent operation normally, which means if for whatever reason your operation fails, like a write operation fails, they would advise you to have an idempotent operation so that you can just retry it again. But with a counter, you can't do that, because it'll just probably, you don't get a notification, but behind the scenes it worked because it's a distributed system. Yeah, that's some of the problems that you can have with counter. We are coming with collection columns. We have set, list, and map, just like in Java. You have these size limits. I'm going to go quite quickly, but if you want me to slow down, you can always ask me to slow down. So there's a set. Here, email. As you can imagine, set does not contain duplicates. You don't want to have duplicate email addresses in there. And here's how you do a set insert, and then you do a set update. Yeah?
Did you have a set of sets or a set
No.
of maps?
No. You cannot have a collection within another collection. That is not allowed. You only use one of these, but you can have a user-defined type. I'm going to get to that in a bit. In a user-defined type, you create a user-defined type, and inside that user-defined type, you can have, for example, address can be a user-defined type, and inside that, you can have a set. That could be possible, like contact information, and in there, that could be user-defined type, and in there, you can have a set of email addresses within the contact information. That is possible. But normally, with a set, map, or list, you cannot have another collection within a collection. And this is how you remove it. The key is that you use that curly braces for set. And obviously list, you can have duplicates, and for the list, you use the square brackets, right? That's the update. And for a map, you use the angular brackets, just like in Java. If you're coming from Java world, it's all easy peasy, right? Update, and how you can actually
That's actually JSON.
Yeah, that's true. They are using a sort of this is a Java notation of declaring a map. Yeah, with the generics, they use the angular brackets. So they use the angular brackets of key and what is it called, the key and value. And here you use a JSON-like notation.
Oh, but that's completely valid JSON.
Well, with the
Process.
yes, but okay.
Double quote? No. Okay. Sorry. Just replacing by double quote.
Okay, well, I don't want to go too much into it because I still have a lot of slides to complete. So I'm just going to stop right there. But you know what, it's sort of syntax. I mean, there's nothing in it. You just use a syntax. That's how you have to do insert, update, and delete. Yeah, there's nothing more to discuss in there. But